Hi guys, today we're going to take a look at page 6 of the Unit 3 Classwork packet. Now, what we're going to discuss today is how the properties of equality can actually be transferred quite easily to talking about segments. Recall that line segments, right, are portions of a line between two endpoints. Let me say that again because that's like a guaranteed EOC question. A line segment is the portion of a line, or we can say the piece of a line, between two endpoints. Now, if we're going to be extending the reflexive property to congruence, okay, so let me write reflexive. Here's what that means. Reflexive is the same thing as the same thing. So when we talk about segments, it can be written either like this: segment AB is congruent to segment AB, or sometimes you might actually see them change the lettering, especially when we get to triangle proofs. All right, so I want you to write down both of these. All right, these are exactly the same thing, but sometimes it might be presented as AB is congruent to AB, sometimes as BA is congruent to BA, okay? Now, symmetric property, which I'm gonna write right here, remember that's switching around an equal sign, right? So the symmetric property of congruence is just switching around a congruence sign. So I would say that this means that AB is congruent, let's say, to BC. Another way of saying that is BC, don't forget my segment marking, is congruent to AB. That's a symmetric property of congruence in a nutshell. They just switch around an equal sign. The transitive property is a little tiny bit more complex, so let's go through that one a little bit more slowly. Here's what the transitive property says, okay? If AB is congruent to BC and BC is congruent to CD, notice something nice here. Which segment is shared between both statements? This one. So what I can do is I can just cut it out and set AB equal, or I should say congruent to, CD. So the way that I remember transitive is I look for something that's shared between the two statements. In order to write my final statement, I just cut out the shared part and smash the other parts equal to each other, or in this case, congruent to each other. All right. Now, the definition of congruence, right? Essentially, right, if we're saying that two segments are congruent, that just means that they are equal in length. So what I could say, we only need to fill in one set of blanks here, right? So I could say if segment AB is congruent to segment BC, what does that actually mean? That means that AB equals BC. It's kind of redundant actually in some ways, but essentially congruence means that they're equal in length, and that's what that's saying right here. Now the definition of a midpoint, this one actually really helps to actually see a picture, okay? What does a midpoint do, guys? A midpoint splits a line segment into two congruent parts. So let's say I have this line segment right here, line segment AC, and B is the midpoint. So if I want to show that in the diagram, I would draw these tick marks to show that those two pieces are the same. And what does the midpoint tell me? It tells me that segment AB is actually congruent to segment BC. Or sometimes you'll see it named as CB, but it's reversible, okay? And so that right there is how you would see the definition of a midpoint. And that's the kind of statement they would be looking for on the left-hand side of a two-column proof. Last but not least, my personal favorite, this is our small plus small equals big, right? So I'm actually going to be a little bit lazy here, and I'm going to use the same diagram, but I want to do this as a segment addition. Notice that this particular segment has two smalls, AB and BC, right? And it also happens to have a big, which is AC. So if I'm going to write myself a segment equation here, what I'd say is that AB plus BC equals AC. And later on in the proof, I could use substitution to actually put some values here and solve for a variable or whatever the case might be, all right? But it is important to have an idea of what these look like because they may show up in the context of two-column proofs on the exam. In the next video, we're going to take a look at how to actually fill in two-column proofs for segments specifically, and that is something that you will be asked to do on the EOC. You can be asked to do it with segments, potentially with lines, possibly with triangles, or with quadrilaterals. So even though I can't tell you exactly which particular topic it's going to be assessed with, you will see 2-column proofs on your geometry EOC, and you will be asked to fill in the missing pieces.